In this video, I will go over a copy of the midterm preparation quiz to help you get ready for your proctored midterm. So question 1 on the midterm prep quiz and also on the midterm will include a statement about honesty and then also formulas that will be available to you during the midterm. You can come back to question 1 for these formulas if you need them. Okay, let's go ahead and go through the questions on this prep quiz. Survey questions may be misleading if they are loaded. To what does loaded refer? So what does the word loaded mean? What is that talking about when we're looking at survey questions? And if a question is loaded, it's intentionally worded to get a certain kind of a response. Refer to the sample of body temperatures in the table below. Given these temperatures, what issue can be addressed by conducting a statistical analysis of the data? So we have 5 subjects and we measured their temperatures at 8 a.m. and at 12 a.m. So let's look at the answers. We could find the percent of people whose body temperatures increase with illness. Well, the problem didn't tell us anything about illness. Is there a difference between males and females? We don't know if these are males or females in the table. The data can be used to address the issue of whether there's a correlation between the temperatures at 8 a.m. and 12 a.m. That sounds pretty good. And the data can be used to address the issue of whether there's a correlation between the temperature and the exposure to sunlight. And they didn't tell us anything about sunlight. So the best answer here is answer C. Which of the following consists of discrete data? Remember what discrete means. Discrete means separate numbers. So discrete here would be the number of suitcases on an airplane. A particular country has 50 total states. If the areas of 30 states are added and the sum is divided by 30, the result is, I'll let you read that number. Is this a parameter or a statistic? So they've taken a sample of the 50 states. So it's going to be a statistic because it's a characteristic of a sample. If they had measured the area of all the states, it would have been a parameter. An animal shelter collects the following data about the dogs they house. Which of these answers is categorical? So categorical here is going to be breed, puts the dogs into categories. State whether the data described are discrete or continuous and why. The number of programs installed on computers. So again, this would be discrete because we can count up what they are. They're going to be 1, 2, 3. They can take on only a certain number of values, and so that's going to be discrete. Determine which of the 4 levels of measurement is appropriate. Placement of swimmers in a swim meet. So the placement here, there's an order to them, but there's not we can't measure the difference between first place and second place, so this is going to be ordinal. Blank is used when subjects are assigned to different groups through a process of random selection, and that's going to be randomization. Identify the type of sampling used. A research team wants to study the demographics of college students in the U.S. using proportionate samples of students in majors reflecting actual U.S. percentages. So they're going to go within the majors and take a sample within each of those, and that's what we call stratified. So we have them into groups with a common characteristic. A study is conducted to measure children's growth rates without any treatment applied to the children. So it's not an experiment, it has to be an observational study. Identify the type of observational study in this situation. A group of subjects diagnosed with lung cancer was identified. Then researchers reviewed their medical records to determine whether they had ever smoked or been exposed to asbestos. So this is going to be a retrospective study. They went back in their medical records to see if they could find out if they had been smokers or exposed to asbestos. A blank helps us understand the nature of the distribution of the data set, and that would be a frequency distribution. Identify the cumulative frequency distribution that corresponds to the given frequency distribution. So remember, in a cumulative distribution, it's the first category, the 0 to 29, is going to stay the same. And you can actually take a look at the answers here and kind of get an idea where we might be going. So this is going to be a 4. It's going to stay as 4. And then we're going to continue, and then the next category, so we're going to go now from 0 to 59, so up to 60, and we're going to have now 20 cars. So that's going to be 20 in the next category. And then we're going to keep going, and then we go 20. Now we've got 20, and then when we add on the next category, we've got 20 now plus 60 is going to give us 80. So now we're up to 80. And again, that's looking down here because we're doing a cumulative one. And then finally we get to 100. So the correct answer here is going to be D, cumulative frequency distribution. A nurse measured the blood pressure of each person who visited her clinic. Below is a relative frequency histogram for the systolic blood pressure readings for the people aged 25 to 40. The blood pressure readings were given to the nearest whole number. Approximately what percent were between 110 and 139? So 110 is here, and then up to 139 is going to be here. So we're looking at three categories here. So this is a 35 here, so I could put a 35 on top. We're getting a percent for an answer too. And then we've got right here a 25, so now we're up to 60. And then we've got a 15, so it looks like my answer is going to be 75%. The table below shows the frequency distribution of rainfall on 52 consecutive Sundays in a certain city. Use the frequency distribution to construct the histogram, and then they want us to tell them whether or not it has a normal distribution. So we start really high here at 26. So let's look at my graphs here. And I notice this one's starting at over 30. This one's at 26 here. Then we drop down to 11, and then a 3. So it looks like the correct answer here is C. Now, is this a normal distribution? Remember, normal distribution from the frequency distribution, we would start low, work up to a high, and then drop back down to low. So this is going to be no, and it's going to be what? It's not symmetric. It does have a maximum, but it's not symmetric. The table shows the magnitudes of earthquakes that have occurred in the last 10 years. Use the frequency distribution to construct a histogram. Does it appear to be skewed? If so, identify the type of skewness. So we've got a 13 and then a 14. So let's take a look on our graphs here. This one looks like it might be good, 13 and a 14. But then it's keeping the frequencies pretty high, and I see that's not true in the frequency distribution. So this is going to be D. And now we've got skewness here, right? Because the histogram has a longer right tail. So the distribution is skewed to the right. A blank is a graph of each data value plotted as a point, and that's going to be a dot plot. We utilize statistical blank to look for features that reveal some useful or interesting characteristics of the data, and that would be statistical graphs. The weight in pounds of 22 members of a junior varsity football team are listed below, and we want to determine which would be the correct stem plot. So let's take a look. We've got a 144 and a 144. So I see two of those here on the left side. On the right side, I don't see any 144s, because imagine this, if I could draw a line right down here, this part here is the stem. Oops. And then the numbers over here are the leaves. So the correct answer here is going to have to be A. And if we continue, we can see a 152 and a 175 and a 142. So the correct answer here is going to be A. And we've got an ice cream company, and they're always trying to create new flavors of ice cream. They're marketing 3 kinds to find out which one has the best chance of becoming popular. Okay, so they have 20 people, so we've got a 20 here, at a grocery store. 4 of them wanted strawberry, so we've got 4 for strawberry. And we have 12 for chocolate. Looks like chocolate's pretty popular. And then 4 for orange. And they want us to construct a Pareto chart. Okay, so Pareto chart, remember on the left bar, it's going to be the highest, and then it's going to move its way down. And we've got the highest one here for chocolate. So I can go ahead and eliminate A, because A doesn't show that as the highest preference. This one shows it, and this one shows it. Now, if you take 12 and divide by 20, you do get 0.6. So the Choco Nuts is correct here. Then you've got 4. If you take 4 and divide by 20, let's go ahead and do that on my calculator. Let's pull up the calculator here and show you that. If I can just find my calculator, which I can't seem to do. Let me just do it off to the side. So if I take 4 and divide by 20, I think I get 0.2. So 0.2 and 0.2 is going to be showing up here. So the correct answer here is going to be C. Fill in the blank. A value at the center or middle of a data set is what? And that's going to be a measure of center. Consumer Reports collects data on the cost of new appliances. A sample of 32 refrigerators has a total cost of $49,568. What is the average cost? So the average cost is going to be, and I found my calculator there. So what we can do here is take that cost, the $49,568, and divide by the number of refrigerators, which was 32, and we get an average cost of $15.49. So $15.49. So you're going to do a little calculation on your calculator, but you're really not going to need to use StatCrunch for any of these problems. Which measure of variation is most sensitive to the extreme value? It's most sensitive, and that's going to be the range. As part of the National Health and Nutrition Examination Survey, subjects were asked how long they slept the preceding night. Results from 12 subjects are shown below. Use the range rule of thumb to estimate the standard deviation. So the range rule of thumb, what does that say? It's the range over 4 estimates the standard deviation. So we need to find the largest and the smallest value. Don't always assume that the largest is on the left and the smallest is on the right, because it frequently is not. So I see the largest value here as 10, and I see the smallest value here as a 3. So I'm going to take 10 minus 3, and I'm going to divide by 4. So let me pull my calculator up again. So 10 minus 3, and then I'm going to divide by 4. And so I'm going to approximate it, and said 1 decimal, so at 1.8, and it's 1.8, and we're talking about hours here. The body temperature of a group of healthy adults has a bell-shaped distribution with a mean of 98.26 and a standard deviation of 0.65. Using the empirical rule, find the approximate percentage below. What is the approximate percent of healthy adults with body temperatures within 3 standard deviations? So if you know your empirical rule, you know that number is 99.7. So that's a pretty easy one. Now the second one, they've given us 2 endpoints and asked us what percent of adults, and they don't tell us how many standard deviations it is. So I'm going to need my calculator. So I'm going to take 99, upper bound, 99.56. I'm going to subtract the mean they gave me, which was 98.26. And then the value of the standard deviation, notice, is 0.65. So I'm going to divide by 0.65, and it tells me that's 2 standard deviations above the mean. And so I know that that's going to be 95% of the data. And I could just confirm on the other side by taking 96.96, subtracting 98.26, divide by 2, and you'll find that's 2 standard deviations below. In modified box plots, a data value is a blank if it is above the 3rd quartile plus 1.5 times the IQR, or below the 1st quartile minus 1.5 times the IQR. And that's going to be identified as an outlier. Scores on a test have a mean of 66 and a standard deviation of 9. Michelle has a score of 57. We want to find her z-score. So her z-score is going to be, her score was 57, and we subtract the mean of 66, and we divide by the standard deviation. And again, if I pull my calculator up, I'm going to take 57 minus 66, and divide by, I don't remember my standard deviation, 9, divided by 9, and so I get a z-score of -1. So Michelle's test score is 1 standard deviation below the mean. The box plot below shows the weights of a random sample of orange M&Ms. What do the numbers tell us? So I'm going to make this a little bigger. You can see it a little bit better. So the minimum here, here's the minimum. I'm not going to type the numbers in. I'm going to let you read those. There's the minimum. The 1st quartile. Now here's where you have to understand reading a box plot. This is an outlier here. This is the lower fence. Here's Q1. Here's the median. Here's Q3. And here's the maximum. So you want to make sure you understand how to read. Oops, I need to do that. How to read the box plot so you can fill in the values on a problem like this. As a procedure is repeated again and again, the relative frequency of an event tends to approach the actual probability. And what is this known as? This is known as the law of large numbers. You are certain to get 3 jacks when selecting 51 cards from a shuffled deck. Express the indicated degree of likelihood as a probability between 0 and 1. If you're certain or sure to get something or for an event to happen, that probability is 1. Use the given probability value to determine whether the sample result could easily occur by chance, then form a conclusion. A study addressed the issue of whether pregnant women can correctly predict the gender of their baby. Among 104 women, 57 correctly predicted the gender. If the pregnant women had no such ability, there's a 0.327 probability of getting such a result by chance. What do you conclude? Okay, so the sample results could easily have occurred, okay, because that probability is greater than 0.05. So it appears that there is not sufficient evidence to conclude that these women can correctly predict the gender of their baby. In a genetics experiment on peas, 1 sample of offspring had 427 green and 45 yellow. Based on these results, estimate the probability of getting green. I'm going to do that first. So I need the total. So let's get my calculator up here. So I need to take 427 plus, start again. 427 plus, the other number was 45. 427 plus 45. So I've got a total of 472, and I've got 427 green. So I'm going to take 427 and divide by 472. And that probability is 0.90, and I don't know if we had to put that in there. Yeah, it is. And there are 3 decimal places. Let me get my calculator back up. So 0.305, 0.905 rather, 905. 905. Is this probability reasonably close to 3/4? Well, it's not very close, is it? Nope. 3/4 would be 0.75. To the right are the outcomes that are possible when a couple has 3 children. Assume boys and girls are equally likely, so there's 8 outcomes here. Find the probability when a couple has 3 children, there are exactly 3 girls. So there's only one outcome with 3 girls right down here. So the probability of that is just going to be 1 out of 8. 2 events are blank if the occurrence of one does not affect the probability of the occurrence of the other, and that's called independent. Use the data in the following table, which lists the drive-through accuracy at popular fast food restaurants. Assume the orders are randomly selected. If an order is selected, find the probability of getting food that is not from restaurant A. Okay, so in order to do this one, I've got to look over on my notes here because I already added these up to the side here. Not from restaurant A. So the total in this table, I added all the numbers up. The total here is 1113. And in restaurant A, there are 364. So I'm going to go ahead and put that over here, 364. Whoops. So not A is going to be what? So I'm going to take let's get my calculator. So if 364 were from A, then the rest of them are not from A. So 1113 minus the 364 that I had from A. So 749 are not from A. And then I'm going to divide that by the total represented in the table, which is 1113. And I get a probability of 0.674. 674. Okay, now in this one, we want to do the probability of getting an order from restaurant A or an order that is accurate. Okay, so now you need, again, the total here is a little different. It's 1099 on this table if you add all the cells up. And then for restaurant A, in this case, there's 353. And for accurate, it's 965. And then remember our formula for probability of A or B, and then you need to also consider the number here. So the probability of A or B is the probability of A plus the probability of B minus the probability of both. So what I need to do is I need to take the total from restaurant A plus the total accurate and then subtract the number of orders that are both from A and accurate and then divide by the total. So let's put it down here. So I've got 353 plus, that was restaurant A, plus I need the total accurate, which is 965. So I've got 1,318, but then I have to take away the 322 because that's been counted in each of those totals, minus 322, 996, and then I'm going to divide by the total in the whole table, which is 1099, and I get 0.906. So this is 0.906. Now the question is, are the events disjoint? And they're not disjoint because it is possible to get an accurate order. It is possible to receive an accurate order from restaurant A, which is the 322 right here. Confusion of the inverse occurs because we incorrectly believe. By the confusion of the inverse, you're confusing that the two conditional probabilities are equal to one another, and that's the first answer there. The probability of B given A is not equal to the probability of A given B generally. Find the probability when a couple has 2 children, at least one of them is a boy. Okay, this is a pretty easy one to do because we know if there's 2 children, there's 4 outcomes. and 3 of those are going to have at least a boy in them. So the probability here is going to be 0.75 or 3/4. That's a pretty easy one for an at least problem. Refer to the table which summarizes the testing results for a certain disease. A test subject is selected at random and tested. What's the probability they have the disease given the test is negative? Okay, so we're only looking at the negative results. So for negative result, we have a total of 321. And we want to find the probability that the subject had the disease. So that's going to be 9 over the 321, which is pretty small. So let's get our calculator up. So 9 divided by 321, 0.028, which is answer D. Fill in the blank. The blank of a discrete random variable represents the mean value, and that's the expected value. Expected value is the mean of a discrete random value is called the expected value. Ted is not particularly creative. He uses the pickup line, if I could rearrange the alphabet, I'd put you and I together. The random variable X is the number of women Ted approaches before encountering one who reacts positively. Determine whether the probability, it is a probability distribution. Okay, so if it's not, then why? Okay, so let's look at the probabilities here. If it was a probability distribution, they have to all be between 0 and 1, which they are, but the sum of these has to be equal to 1, and it's not. So this is going to be no. The table below describes the results from a group of 8 births from 8 different sets of parents. The random variable X represents the number of girls. Using the information, find the probability of getting more than 5 in the 8 births. More than 5, so that's going to be the last 3 groups here. And if we add those up, we will get I think it's 144. Let's check on our calculator. So 0.109 plus 0.031 plus 0.004, 0.144. So all I did was read that right off of the table. 144. All right, and the main goal in statistics is to interpret and understand the meaning of statistical values. The blank can be very helpful in understanding the meaning of the mean and the standard deviation. And the answer here is the range rule of thumb, and this is the range rule of thumb for significant events. So don't confuse that with the range rule of thumb from an earlier chapter. Estimate whether the given procedure results in a binomial distribution. If it's not, say why not. So we surveyed 200 homemakers and recorded how satisfied they were with their toaster on a scale of 1 to 5. So there's more than 2 outcomes here. So it's not because there are more than 2 outcomes. Let's see, no, because there are more than 2 outcomes. So it's going to be C. And then finally, in a Gallup poll, 66% were worried about identity theft for a group of 1,013 adults. What's the mean of that? So the mean is simply going to be 0.66 times 1030, 1,013, 1013. Oh, clear that out. 1013 times 0.66, and you'll have this formula, and we're going to round it up, so it's going to be 669. That formula is in question number 1. So hopefully this will help you get ready for your proctored